All right, welcome back. And we're going to do question 1, which is the traveling wave question on quiz 3. So to start off with, we're going to haul out our usual questions of what do we want? What do we have? And what connects them? So to start off with, what do we want? So we want to find. Find is a good keyword. Find the solution to u of x of t for the 1D wave equation, blah, 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 under these conditions. So this is definitely what we want. So we know that our answer is going to be in the form u of x and t is equal to something. Now, the next question is, what do we have? So we have a 1D wave equation. And if we remember the generic form of the 1D wave equation, 1 over the velocity squared partial of u with respect to t. And the key that it's a traveling wave is that we don't have boundary conditions, or we don't have a full set of boundary conditions on x. So traveling wave. So x can range over anything. Likewise, if it was, say, 0 to infinity, that would be a good cue that this was a traveling wave problem. If you had the function restricted at a point, either in its value or its derivative, that's a strong indication that it's not a traveling wave type of problem. Okay, and then finally, we've got some initial conditions. So we've got that as a half, and we've also got u. So we've got some initial conditions here at t is equal to 0. And, oh, almost forgot, and 0 otherwise. So this is a step function. And we also know that the initial velocity is 0. So every problem that we've done with traveling waves has had this condition of partial of u with respect to t, evaluated as t is equal to 0 is equal to 0. And something that you should remember is that the general solution in this case, and let's switch over to a different color, u of x of t, when we have this particular initial condition of, oh, I didn't like that. Let's undo that. Bad idea, bad idea, bad Eric. So when we have this, we have a set of traveling wave solutions, f minus ct plus 1/2 fx plus ct. This is our general solution to the traveling wave equation. With 0 initial velocity. So now what we need to do is figure out what c is. So we can take and notice that in here we've got 1 over 4. And here we've got 1 over, let's undo that. We've got 1 over c squared. So by matching the general PDE to our PDE, we've got partial of u, partial of x squared. I'm being very pedantic here, by the way. You don't need to be, this extensive. Is partial of u, partial of x squared, 1 over 4, partial of u, partial of t. So that means that 1 over c squared is 1 on 4. So c is equal to plus or minus 2. And those two c values show up here and here. So if you instead, you wanted to be cheeky and you said, oh, c could be equal to -2 instead of +2, you need to get the same answers in that this part here has got a positive c and this part here has got a negative c. And this just represents a wave traveling to the right for increasing x as t increases, and a wave traveling to the left. So we'll just label that this is the travel left, and this is travel right. Okay, so let's substitute that in and get our final answer. We've got then u of x of t is equal to 1/2 f of x minus 2t plus 1/2 fx plus 2t. And that gives us our answer. Now we could go through and we could substitute in f of x if we wanted to or needed to. So f of x, going back to this definition, is equal to, it's a stepwise function, 1 for x between -1 and 1. And it's 0 for, this would be x less than or equal to -1, or x greater than or equal to 1. And I'm just being careful on my bounds that, here we're not overlapping with 1, and here we are overlapping with 1. So we could proceed to substitute in if we wanted to. And be sure to check how the problem is worded to see whether we're asking you to substitute or whether you're able to finish things off by just leaving it in this particular form. Mathematicians are lazy people. It's very, very important that we're lazy because there's a whole lot of math that we're not doing by being lazy, which of course then means that we can do more math, but different math, interesting math, hopefully useful math. All right, see you soon.